webcast is now starting. All attendees are in listen-only mode.
Thank you for joining us today for the webcast Industry 4.0. What does it mean to the ergonomist? Presented by the Applied Ergonomics Conference Committee. I'm Carol LeBlanc, and I'm the moderator for today's webcast. I have a few opening instructions before I turn the program over to today's presenter. During the presentation, all audience members will be muted. We'll take questions after the presentation. Please type your questions in the questions box on the webcast interface. Craft the wording of your question as clearly as possible. And now I'll turn things over to today's presenter, Allison Stevenson.
Hello, everybody. Nice to be here virtually, which is only appropriate because we're going to be talking about Industry 4.0, which has lots of virtual connotations to it. So I'm going to start with my opening slide here, which I can't make it go to. Okay, Carol, oh, there we go. It's a little slow. Okay, so today I'd like to talk to you about the role of the ergonomist and the opportunities with Industry 4.0. This is a trailer to the presentation that I'll be presenting at the Applied Ergo Conference this coming March. I think we were originally going to have Julia was going to give you a little pitch about the Applied Ergo Conference. So since I have it up and I'm talking, I'll give you a pitch. I hope to see you there in March. I'm really excited about it. And this will be a master track. So today is really going to be a trailer, like the movies. I will touch on some of the topics, but won't go into a deep dive of what all the aspects of Industry 4.0 are, because there's a lot of them. So I hope you'll join me at the master track, and we will go into deeper dives, give examples, and play. So let's get on to a little bit of what does Industry 4.0 mean, and what does it mean to the ergonomist? So you have to start off with the definition of ergonomics, just so we're all on the same page. The big part here is not that I'm going to read you the definition of ergonomics, but I challenge you to think, is there really anything that doesn't have the human interfacing with something? And if that is the case, then we obviously have an ergonomic interaction. We have something that looks at that interaction. And with Industry 4.0, even though it's got a lot of virtual and computing and robots, there's an awful lot of interaction between the human and that new environment. And that's what we're going to explore today, and those opportunities. So I'd like to say that I come to you with lots of experience. That does make me old, so you have to work with me on this. We did a lot of testing beforehand, and I am not sure that this video will give you sound. So I'm not going to play it, but we'll send this link out, and you can enjoy this in your own environment. It really is a little bit of background about me, and it's much nicer if the video does it than me, but given that my video doesn't have sound, I'm going to actually, I'm going to play it because I'll talk to it a little bit. And then, like I said, you can, I know that you'll be able to see it, but not hear it. So I come from the Ford background. I know many of you know me. I've been attending the Ergo conference for many years. And in the Ford situation, I ended up in a situation of the reactive ergonomics and then moving into a proactive ergonomic role. So I'm going to talk to you a little bit about that. When you move from a reactive program of injuries to this, how do we look at how we design something? It's much like where I feel we are as ergonomists today, which is we're sitting on this edge of Industry 4.0. It means lots of new things we've never done before. And how do we then anticipate as an ergonomist and those ergonomic challenges that we're going to have? How do we anticipate that? And that's how I feel that I was doing with Ford when we were going into new technology and how do we look at the assembly line of the future and what would the role of the ergonomist be when I don't have workers to do a task analysis on? How can I look at the design and how can I influence that design to make sure it optimizes our human? So that's what we're going to do. A little bit of exploring is what are these new technologies, new methods, new ways of doing stuff coming down the pipe that we'll be able to look at, and what challenges is the ergonomist going to make? So a lot of this video, again, I know you can see the video but not hear it, is showing our use of the virtual, which is part of the new technology in Industry 4.0, and I'll explore that a little bit with you as we go. Okay. I'll let that run a few more seconds, and he's just talking. Okay. Thank you. Okay, so now escape and go back to my PowerPoint. Okay, so I hope you're all with me. We're back here on the PowerPoint. I'm hearing background noise. Sorry. I need to bring these down. Okay, sorry about that, guys. Okay, so let's talk about traditional ergonomics. I'm going to try and connect the dots or build a foundation to understand why I think Industry 4.0 is going to be challenging and also exciting. But to me, it's a little bit of, it's like a tree, and all good ergonomics has to have a good foundation. And then this Industry 4.0 is just going to challenge us and be many, many branches. So when I talk about traditional ergonomics, I mean that we are looking at where our problems are, and we go after those and do our traditional task analysis. So in order to determine where an ergonomist should be interfacing, we usually analyze the operations on the plant floor, we talk to our operators, and we apply our analytical tools. We can call ourselves a little bit up front as we get into prototype evaluations. So this is before production, but we have some physical prototypes that we can do ergonomic analysis on. So in this case, looking at a new side bag that was going, a side airbag going in, and we're looking at her overhead reach postures, do some analysis of that, and then make some recommendations on either the design or the process from those prototypes. So it's really an injury-driven process, and I'm going to say that that's a great place to start. If you have operators that have concerns, have discomforts, and like me in the automotive, we've been building cars for 100 years. We should know where some of our problems are. So this is a great place to start, and this is where I want you to all consider. It's all coming from where the injuries are going. So the problem we had, though, is after a new launch of a vehicle, you can see there in the middle of the screen, we would see a spike in injuries. And that was a reflection of we just were going in with the same problems that we had identified. Maybe we'd even fixed them, but we weren't able to carry over those fixes. So what we found is you'd end up with a new launch of a vehicle, and we would see our overall baseline of injuries would be higher than what the outgoing vehicle was. So this does not bode well. As we were launching new vehicles quite regularly, it meant that our planning and our processes and our setups really needed an improvement. So I'm happy to say that we approached Ford and they agreed that it made much more sense to integrate ergonomics into our engineering process. So what we did was we actually pulled a business case together to actually do that, move from I'll call it chase the injuries and fixing job by job into this idea that ergonomics should be an integral part of the engineering process. So we did a one-time business case so that you don't have to justify every lift table. We basically said, it makes sense from a safety, quality, cost, and morale that we should be doing ergonomics whenever we're setting up a brand new workstation, whenever we're designing a new vehicle. And that was kind of the justification. So let me give you a little bit of an idea. So we looked like that, the tip of the iceberg, and we found that just like the literature says, that the workers' comp costs, or the direct injury costs, are really only minimal. This is old data, so I'm allowed to share it, but just to give you an idea, I actually went and tried to quantify quality, tooling changes, production losses, absentee, and basically it turned out to be about 4 times what my injury costs were. So it was huge savings and huge opportunities that can go into if you can get ahead of these. My also advice is to talk in the same language that your engineers and your management talks. So we were having a lot of medical visits, a lot of lost times at the case. Now I am aging myself. This is way back in 2000, so 20 years ago. But the method that we approach this is something that I want you to be thinking about, because as we get into this new era, I think this is where we have to say we've got to be part of the planning stage. So in this case, telling a plant manager that we're shutting his plant down for 3 weeks means a lot to him in terms of profitability. And in effect, that's what we were doing by having our workers injured. We also then made the link to quality. So some of the ergonomic concerns that we were having is repetitive strain injury here on the weather strip. Turns out that we were also having wind noise and water leaks because the operator was unable to get this weather strip on securely. Main reason is because it was such a poorly designed ergonomics. Glad to say that we've made lots of changes in the weather strip area over the years, but we then showed a strong link that if it's set up and designed so that it has injuries coming from it, it is also highly linked to the quality of the vehicles. And then more and more we're seeing that it's just the right thing to do, to set your jobs up so that they optimize human performance is the right thing for a company to do. So it affects our absenteeism, poor quality of life, and low job satisfaction when your operators feel that they are overworked and that the jobs are difficult and could potentially injure them. So this was a lot in the morale and awareness that went into that. So in the end, we basically convinced at a high level that we were going to go after these injury costs, but we were going to do it up front. We were going to use virtual manufacturing tools. We're going to use new technology, and that the ergonomist would be part of the planning stages. And we would do this before an injury. So the future of manufacturing for us in the automotive sector was really at the start of the 2000s. I would now challenge you then to say this Industry 4.0 is going to be the start of where you can take ergonomics and use these new technologies to then bring into the future. So we had great results. So I'm happy to report to you when you do this upfront planning, we did get our little spike. I equate this to when you have your first snowfall and everybody brings out their shovels, and then the next day they're feeling the pain. So we have new jobs, new stresses, things like that, but then we see a nice reduction after that, and we settle down at a nice level because we've got some good planning. We understand what the risks are that we've brought in. And we're seeing, lots of this then it's a lot cheaper to fix things when they're in the virtual time frame than when they're already in production. You've already got your tools and things like that. So again, we can leverage some of this Industry 4.0 and the technology it brings to be able to drive ergonomics into the design phase. So one of the most powerful tools that we used was the use of digital human models. So you're going to see more and more of this coming. One, we need input. A model is only as good, or the output of a model is only as good as the input into the model. And we all know how complex the human body is. So there's a lot more advances that need to happen in the digital human model. But the fact that we can actually pull in CAD data, do evaluations of an engine and hand clearance and this, how much efforts are going to be used before this car goes even into production is a really powerful tool that I think is going to be available to us much more in the forefront in Industry 4.0. So I even want you to even think a little bit of this. So I have this digital human model, I can analyze it, but if I don't actually have a human and I don't have someone doing that action, how am I going to analyze that job? So we leverage technology in the motion capture where we actually immerse someone. They could see the CAD drawings of the future, immerse them inside those CAD drawings, get them to reach to those locations, and then we reverse engineered and said, in that posture, what would be the maximum force that I could push this hose on? And so as you see here on the top of the screen, for the lower rad hose in this posture, we ended up giving a target of 26 pounds to our engineers. So this is really using technology of the digital human model, the CAD, a motion capture to get a posture that they will be working in the future, and then reverse engineer to say what would be the maximum that muscle could perform in that posture. And we converted that into an engineering specification. Really exciting and really a good demonstration of using technology. When we did this, we saw some phenomenal results, right? As you can see here, almost a 90% reduction in our lost time cases. So a really strong case that embrace this new technologies. So, Ford has been enjoying, and I know a lot of other industries have been enjoying all-time lows in injury rates. It doesn't mean we're at zero. I'd love to say that we are, but we're continually improving, and that's really exciting. But the message is that proactive ergonomics works, and I'm excited that the future is going to have even more an exciting technology and opportunities for us to drive that optimization of the human. So when I say Industry 4.0, let's just think about that. Here's kind of a timeline of some of the technologies out there. Industry 4.0 means a really connected future. There's going to be virtual reality, augmented reality. Here are some of the items that people are talking about. Big data. And big data, it's so big, it's really even hard to contemplate. It's all that data that's kind of been out there that we're collecting potentially on wearables. And how is this all going to be integrated? Autonomous vehicles, autonomous robots. So there's going to be so many more interfaces and new technologies that I think it's really exciting on how we're going to leverage that. I love the idea of a disruptive innovation, and this comes from this video. I'll let you watch that there. But in this picture of the same street in the 1900s, there's actually only one, it's all horse and buggy. And then in 1913, all the horses were gone, except for I think there's one horse, and it's all vehicles. So that same thing, what is the disruptive technologies? I think there's many of them that are coming out. And if you'd asked us about that, it doesn't mean that the car was going away. As a matter of fact, the car is changing, but the mode and was changed dramatically. And I think that's what's exciting, is that we've just got new technologies that are going to bring around new opportunities for us. So one that I see is a big one. And again, I've got to keep an eye on my time here. I could talk all day about this, So come to the master track, because we're going to get into it a lot more and I'll have a little bit more time. So I'm going to give you a little dabble of some of the ideas that I think are going to be big in Industry 4.0, and we'll explore in more detail then in the master track. So there's this idea of simulation. I think you can all kind of gather that. This means having a digital human model kind of perform jobs to do that. But there's this idea of a digital twin, meaning that your factory would actually be able to be accessed, and the data from it and the monitoring of it can be done right from an engineer's office or from your desktop, and you'd be able to problem solve, identify when issues are there. And this can even be expanded to, when there is issues that are coming from an operator, that you'll be able to voice in and give direction remotely. So there's a lot of, I believe, cognitive demands that we're going to have to be aware of from an ergonomics role, but also this idea that we're going to be able to do ergonomics from one location and touch people all over the world, which I think means that we, from a travel perspective, our efficiencies, and I think there's a lot to be thought about that. So let's see what I've got next here. So from my perspective, we started at Ford a little idea of having almost like a Google Earth, and I'll go into that a little bit more in the master track, where each of the assembly line could show you not only a simulation of what that job was expected, but actually have some live feeds of what was happening there. And then back into this planning, we could understand what was the design intent. So here the design intent was you would reach in like this. We calculated that it would be 6 pounds in each load would be the acceptable. And then we validate then with online and big data that that's exactly what is happening all over the world in different locations, that our operator is performing the task as intended and as designed. That's really exciting and really powerful. So there's a lot that's going on here. The use of digital human models. I think there's even a lot in the research world of making these models better. I know we didn't have a lot with our hands and fingers, so I think this is an area that will give us some opportunities. I'm going to continue on just due to my great ability to talk about this exciting topic. So let me see if I can get the slide to go. There we go. You may have all heard of this, the Industrial Internet of Things. I find this a little confusing because what else would the internet be but of things? But I think the advantage here, or the thought process here, is that we're all going to be living in a connected world. So I know that there's technology out there. You can turn on your heater, your heating. You can watch your surveillance. So the same idea goes that we're all going to be connected, and the data around human performance and how how workers are doing their job and how we design the job, that information is going to be readily available. I think this is going to be very powerful for us in ergonomic assessments. We'll be able to then streamline that data and filter through it and get some, I hope, better risk assessments. So I'm excited about that. And I also think there's going to be a lot on monitoring the use of wearables, what kind of information we'll be able to grab and make better decisions. One of my pet peeves is I don't want us to take this wonderful high-level knowledge and data and put it back into our prehistoric, I say prehistoric, but into our old risk assessment tools. So we need to be thinking about new risk assessment tools that use this new data that's available and all this data that's available. So connecting that relevant data from humans and interpreting it into better analysis tools on there. So I think that's an exciting one. Then we've all heard a little bit about additive manufacturing. Again, I'll go into a little bit deeper, some great case studies of using additive manufacturing in the ergonomics realm. In this one, we actually used additive manufacturing in Proactive, We detected a hand clearance here in the virtual world, but because you really can't feel it, you don't know what's going to flex and what's going to move. So we had the idea of actually additive manufacturing or 3D printing the clearance envelope in a future model vehicle. And so from that, we were able to make better decisions, add data to the virtual, and decide whether or not it had access. I love this one. I don't know if it's going to work. Okay, maybe not. Okay, so this is actually a little tool. And it is, so some complex tool. This tool actually was 3D printed and allows the securing of the 5 lug nuts or 6 lug nuts. Let me see, 1, 2, 3, 4, 5, 6. 6 lug nuts all at the same time. It was always a ergonomic issue with the pinching and the twisting and turning, and we were hard pressed to make a fabricated tool out of steel, and we were able to come up with a lightweight 3D printed tool that we were able to use. Again, this was a reactive, which is great, but it really is showing the leveraging of new technology like 3D printing to create really unique tools that we had struggled with traditional tool making techniques. Okay, let me see if I can get this to change. There we go. Another exciting one is robots and cobots. I've left the YouTube links. You can play with those, but we have 2 kind of new interactions that I see coming, that the robot here lifting the part, so taking over a role that is not so ideally designed for the human. And then the other one, a robot maybe taking over a part that, we have an autonomous vehicle delivering your part, but how do we get that package to your doorstep? So the use of a robot that's going to interact with humans, the cognitive demands of that, the trust that goes in with that. There's lots of really cool human interactions with robots that I see is going to be a big opportunity for ergonomists in the future. So prevailing belief that robots are here to replace humans, I don't believe that. I think they're here to help us, but I think we have to manage that, right? How do we use them, and how do we use them effectively, and how do we interface with them is going to be a part of that. Now, that means that we do have a responsibility to understand those interaction and the safety around that. And that's a role that I really think that ergonomists are being really can play an important part of. Just a little human here. We're not really hopefully eliminating the engineer, but trying to figure out that role of the worker and the robot. One of my favorite topics, exoskeletons. We're definitely going to go into a deep dive of this at the conference. And exoskeletons originally coming out was a lot of the overhead work, which is still very popular, but we've also seeing some exoskeletons in lifting. We're seeing strength augmentation. Been playing with one called the Iron Hand that adds some support in gripping, and the strength augmentation of adding your ability to lift more than if you were left alone. So I think these are all things that we should be nervous about and excited about. Make sure that we understand where we're putting them. I've used the term, is this a solution looking for a problem? Let's hope not. Let's make sure we understand the parameters around it and where it's going to be most effective so that it reduces risks for us. So there's a lot of opportunity there. Then there's all these new autonomous vehicles coming out, and think of the interface. Oh my goodness, can you imagine this being your commute to work? I'd love it. But am I ready to trust the design and the interaction? So that trust, if you're nervous about that trust, remember the general public is also. And so the role of the ergonomist is to understand what is going to make them nervous, what is going to build that trust, and make sure that we feel really confident about that and help influence that design. I think the human factor and the ergonomist is a key part to that. because it's not only about functionality. There's a lot of emotion that goes in with trust, and I think our profession field has got to play a role in that. And how exciting is that? Understanding the human response, understanding of the interaction. So even though the autonomous vehicle, you say, is taking that human out, indeed, it's actually just changing the role. So the car is going to maybe drive, but at some point there may be, how do you get the driver back in, and how do you get them engaged? And those are the questions that I think are exciting for the ergonomist to address. Okay, augmented reality and virtual reality. Technology that immerses you into a digital environment, and then technology that overlays. So that means that it can be used in sales, training, error proofing, remote assistance. All of these things, if you can look at them, they're not removing the operator or removing the human, but again, changing that interface. So I see some really exciting roles for the ergonomist, that we can use this to better train people, to minimize our injuries, the interface, how this is set up, is some of the challenges that I think we're going to see as ergonomists. But I also think some of the complex solutions that we may have been trying to put in can now be simplified by using some of this augmented reality. So I encourage you, don't be afraid, jump in, and know that I think that you know, your background in human factors makes us the ideal ergonomist or engineer to be able to address some of these challenges that and opportunities that are coming. Think about our office of the future. You know, many of us, how many of us have our calls from our car? You know, who knows what our office will be looking like? And you know, we got to try and fit in our exercise there. So all these new interfaces are going to need some thoughts to optimize and to minimize the stress on the human. So I think I have to leave some time for questions. I'm actually impressed. I'm actually relatively on time. I hope my message has been, oh my goodness, there's so much when it comes to Industry 4.0, lots and lots of challenges and lots of opportunities. I hope to go into a little bit more of a deep dive and give you some examples when we meet in Kentucky in March. But I think I'm going to basically leave you with this message, that the future is bright. I think that ergonomists are going to have to be leaders, and we're excited about that role. But our role as a leader comes in this role as a facilitator, the interface between the worker, bringing in all these new technologies, between management. Change is hard for anyone, and we need to be the champions of that and be part of the decision, what goes into those designs. The great thing I think about ergonomists is that we are problem solvers and critical thinkers. So that I think is going to give us lots of opportunity with Industry 4.0. And of course, one of my favorites is innovation, and where we can see a lot of this innovation. So be an innovator, be a lifelong learner. One of the things that that I love, and you know, I would be amiss if I didn't at least put up my my program. I'm very honored to be teaching the ergonomists of the future. I know I have a lot of my good American friends on here. Did you know that the exchange rate is really good and that you should consider studying in Canada? But for anyone who is looking on that, please check out the website there. And we're looking forward here at the Fanshawe program to support AEC, and we're looking forward to all the challenges that our Industry 4.0 are going to bring for us. Okay, so I am open for questions. I will bring up my chat. I don't, Carol, are you there? Are you able to
Yes,
come in and help me with some of the questions?
Yes, I am here. We do have a question that says a lot of DHM software packages are out there, many with consistent validation studies, primarily on the ergonomics and Industry 4.0. Oh,
Is that a question?
this is it's consistent validation studies primarily on
Okay.
astronomic models and motion simulations. Can you comment on the role of wearables with ergonomics in Industry 4.0?
Okay. So I'm having trouble with the linkage back to digital human models, but I think the question is really asking about data, right? And as ergonomists, we have to filter what data is going to be available to us and how we can use it effectively. So one of the things that I'm excited about digital human models, yes, you're absolutely right. There's a lot that have been statistically validated, and I use them every day and made lots of million-dollar decisions using them. What I believe is going to happen is we're going to get a lot of data about motion, and most of our digital human models and most of our ergonomic assessments are static. So we take this beautiful motion, we freeze frame it into the worst posture, and then we do a joint by joint analysis because that's what we have out there from our epidemiological data. So I think the challenge is that how do you analyze motion from an ergonomic standpoint? So there's a whole idea of momentum and lifting. You know, if you look back at like a NIOSH lifting, it's a static, right? It really doesn't have a good mechanism of understanding that dynamics. Whereas now simulation and even wearables, I can get the accelerations of my arm and accelerations of my fingers and all my motions. That is so much more data than we've ever had before. How can we, and this is where I challenge, you know, our researchers, how do we interpret that dynamic motion? Because we're going to get a lot of wearable type data, and what does it mean? We're going to need more epi data. We're going to need more case study data. We're going to need to analyze a lot of this data. Maybe there's a combination of joint accelerations, joint movements. You know, Bill Maris found with his lumbar motion monitoring that acceleration of the spine was a key risk factor. We don't have that on any other joint, but my guess is that if we had the data about joint acceleration, there may be some linkages there. So I think my challenge to you is digital human model is a great way for a database of us to understand all that data, and now we need to figure out how we turn that into risk prediction.
Okay. It is important to comment that companies in emerging and peripheral countries, ergonomics are unable to convince entrepreneurs and managers to do the bare minimum. There is an extremely unfair exploitation of labor. It is important to comment that companies in emerging and peripheral countries are the same as those present in economically wealthy countries.
Yes, you know, and I would even say, even within the United States, we have small companies that do not have the resources to have digital human models. So I do believe, and you know, that we need to share that. You know, one of the great exciting things that I had with Ford is I was able to work with the U.S. car group, and that allowed me to work with GM and Chrysler. And even though they were competitors, when it came to issues on health and safety, we were able to share. Within a global company, Ford decided that our ergonomic standards that we used in the United States would also be upheld in all of the countries that Ford had assembly plants. So I think it goes back to a little bit of that business case. I understand that smaller companies are doing a case-by-case injury analysis, but I believe that engineers still have to design, and even when you buy a product, so let's say you're in a hospital and you're going to buy equipment. If that's just bought by the user and they don't necessarily even have any engineering background, it's a great opportunity for us to bring those that have some ergonomic background in and ask those questions of the manufacturers of equipment that's coming into our plant, what the thought process were, and if they used any of these technologies in the design of that. So I guess I agree that there's a lot that traditional ergonomics should be there, and I started with that as a foundation, but I also think there's a lot of leveraging that we can use and share in smaller companies and underdeveloped. So I think there's still a lot of opportunity out there on all fronts.
Thank you. Where do you get your maximum acceptable load for the model?
Oh, you need to come into one of my ergo theory and practice classes. That's a whole lecture, but I'll give you it in the logic. So we at Ford said that we were designing for the strengths of the 25th percentile female. So we set up that we would evaluate each body, each joint. So the shoulder joint would be maybe for a push for that rad hose. And we set the model then to say, in that posture, what would the maximum strength that would be acceptable for 75% of the female population. We chose female and 75% because females are weaker than males, and so if you accommodate the 25th percentile female strength, you're accommodating 99% of the male strength. So when you merge those two populations, by setting it to the 25th percentile female strength, you're accommodating 90% of the population. So I can tell you, in that posture, 90% of the population would be able to create a 26-pound, I think that's what the number was, force in that direction. That was a whole hour lecture summarized.
Thank you. The next question, when designing manufacturing of autos, do you take into consideration the ergonomics of a mechanic that must reach into and repair the vehicle? I'm asking in regard to how the parts are arranged in the vehicle.
That's an excellent question. And I used to argue that's a lot. So there are basically in the auto industry, and I'm pretty sure GM and Chrysler and a lot of them do the same. So we have a group on the product side that is very much in the ergonomics of the customer who buys the car. We have the manufacturing side that is looking at the ergonomics for the assembly worker who assembles it. And there's another ergonomics group in what we call serviceability, and that is looking at the serviceability or the ability of the mechanics or our customer who's fixing it to look at it. And those three ergonomic viewpoints do get to have an input in the product design and in the review cases. So I was not in the serviceability, but I was in many meetings where the serviceability ergonomist was there putting in a vote for the mechanics out there.
Okay, I'm just checking. Okay. Also, in one of your slides, the person in simulation of placing a part that had a shoulder in a position of impairment, but that was the desired position of your presentation. I wonder why it should be desired positioning.
So I think what you have to remember is that it's a car and that we are ensuring that the postures that the operator is getting into are safe. And when I say safe, from an ergonomic standpoint, are acceptable to the 25th percentile female strength. So you may see in that, I think it was probably my, let's see if I can go backwards. No, that's not gonna let me go backwards. Previous, okay, let's see if I can do that. Oh, okay, that really isn't working for me. Okay, let me just get back there. So, it's probably this one. So what happens is that all cars need fenders, right? And so what our job as the ergonomist, was it this one? No, it was, our role then is to evaluate whether or not it is acceptable to us. Okay, I'm really having trouble with my whole finding them. Yeah, it must be here. Okay, good. So you're saying that this shoulder, I'm going to say, is definitely elevated. Wow, that was really good, Allison. Okay, I'm having technology different. Can you see that slide, Carol?
Yes.
Okay, so for some reason I can't get it into the slide mode. But anyway, so you're saying that this is an elevated shoulder posture, and it could be. But as you can see from our model, that the limiting joint is the shoulder, but it is acceptable to the 25th percentile female. So we are then saying that this can go into production. We found that this, at least from the side, was a better positioning than maybe coming in from the front of the vehicle. And this is the kind of things, but you got to remember there's 20,000 parts on a vehicle. We're doing ergonomic assessments on installing all those parts. And so you're absolutely right that maybe not all are going to be absolutely perfect and optimal, but our role is to give good guidance that, given the constraints that it is a vehicle and we have fenders and we have consoles and we have steering columns where they have to be for the customer to drive the vehicle, that we ensure that we set the line at the right height, that we can, the operator can see it, and then we check that there's enough strength for someone to be able to do that. And just from a anthropometry, this would be for a small, this would be a small female that would be put in there to make sure the line height was correct. And then a 25th percentile female strength. So I hope that answers it, and they feel that we do as good a job as we can to make sure that all of our jobs have been set up correctly.
Okay, you have another question. Can you comment on the role of wearables for ergonomics and Industry 4.0?
Well, wearables is such a open category. So yes, I think that wearables are going to have a couple of roles. So I think wearables are going to be important for us for ergonomic analysis. It's going to give us much more data that I think will help us make better decisions. So it's going to give us data on joint angles, heart rate, maybe blood pressure, maybe sweat. So I can see some roles in heat stress analysis. I can see some, so there's a ton of data from the human that I think is going to be exciting that we're going to be able to do from wearables from an analysis standpoint. Then there's also data from wearables that we're going to be able to maybe be able to use to optimize. So in the design, so we may be able to use, I've seen some wearables that are saying somebody's slouching, so I'm going to use slouching or bending, and maybe they're going into awkward posture. Like, I'll take this position here. Nothing is making that operator really keep their arm elevated. Maybe they could perform an action that would minimize that elbow going down. So if we were wearing wearables that were behavior mod, there may be some training of, proper lifting or that could be there. So I think there's just lots of opportunities that could be out there in terms of wearables. Then if you extend that to even be exoskeletons or this iron hand that I've been playing with, which gives extra gripping strength, there's definitely going to be, I think, some of that of interest, strength augmentation, if you consider that a wearable. So many fronts that I think ergonomics and wearables are going to, I'm going to say collide, but collide in a lovely way.
Thank you. Please tell me the human error analysis in Industry 4.0.
Human error. Ooh. I think we're going to see more in the cognitive than what we've seen before. So we've, I say we, I know myself, has spent a lot of time in the physical. What are the joint, the analysis that's in front of you doesn't have really anything to do with the cognitive. Even our cognitive PDAs, our physical things, are really about kind of multitasking and things like that. I think that Industry 4.0 is going to be giving us so much data, and data presented in ways that we've never seen it, with heads-up display, with augmented reality goggles. I really think the ergonomists, even those that are very active on the physical side, like myself, are going to have to continually educate ourselves on the cognitive demands and how to evaluate those cognitive demands in Industry 4.0.
Okay, I think we've got time for about another question. Can you elaborate just a bit on why new evolution models are needed to leverage data information that will come with Industry 4.0?
Can you repeat that question?
Okay. Could you elaborate on why new evaluation models are needed to leverage data or information that will come with Industry 4.0?
Sure. Okay. So the biggest challenge that I am seeing is our ergonomic analysis tools are done on static postures, and work is dynamic. But we did the best we could, right? So even our digital human models who do great simulations, when it comes down to compression on the spine, or it comes down to joint torque evaluation, or even fatigue analysis, we do a succession of statics and sum them up. With Industry 4.0, the amount of data that we're going to get that's dynamic, and our analysis tools are not capable, if I can say that, to be able to do the analysis of all that data. So we're going to have to think about dynamic and how to simulate that data and make some injury risk predictions from it. So we've got a great start, and we have the static, and we can rely on that. And so we are doing that. But I think the challenge is Industry 4.0 is going to bring us a lot more data. And as ergonomists, how do we interpret that? And how do we collect that and use that effectively, so that we can be better at analyzing risk and making it, then using it to create better interfaces and jobs for the future.
Allison, we have one more question before we need to close out the webinar. What software would you recommend for ergonomic analysis?
So again, that's another whole hour lecture. It really depends on the task. So in short, I basically teach that you do a lot of different ergonomic analysis tools, and then the ones that are good for repetitive strain injury, I teach, the ACGIH HAL TLV, I use HandPak, I use, they're probably the two that I use for hand. When I do ones like postural analysis and I know it's static like this, I would use a digital human model. We used to use Ford, we used to use the Siemens model, I've used the Santos model, and one that's very affordable is the U of M 3D static strength if you want a biomechanical model. And then, I teach a whole array of kind of all task ones, which would be kind of your Sue Rogers, your Rula, your strain index. If it's a whole task that you're wanting to look at. So there are many. My recommendation is there are a lot of great resources. The IIE has a lot, MSD prevention websites. So I think you kind of have to have an understanding of what the tool's limitations are and then choose the right tool based on the task that you are analyzing would be my best it depends kind of answer.
I'd like to remind the audience that the Applied Ergonomics Conference will take place on March the 16th through the 19th in Louisville, Kentucky. We invite you to visit our conference website and make plans to join us in Louisville. On behalf of the Applied Ergonomics Conference Committee, I'd like to thank you for joining us today and to thank our presenter, Allison Stevenson, for sharing this informative information with us today, and the questions that she was not able to answer at this time, I will forward them on to her for answering at a later date. Within a few days, the recording of the webinar will be made available on the AEC website and the IISE website under Ergonomics. Thank you for joining us today, and this concludes today's webinar.
Thank you.